probably this is what IB likes. They like the old school physics problems.
Let
All
me zoom
right.
back in.
All right. Now this one's all you. So whenever you're ready.
The ballistic pendulum used to be a common tool for the determination of the muzzle velocity of bullets as a measure of the performance of firearms and ammunition. Okay. Nowadays, the ballistic pendulum has been replaced by the ballistic chronograph, an electronic device. The ballistic pendulum is a simple pendulum that allows one to record the maximum swing angle of the pendulum arm caused by the firing of a bullet into the pendulum ball. Let L equals 1.5 and M of A equals 6 kg. Per George Washington's 0.58 caliber pistol, which fired a round ball of mass equals 87 grams, and it is found that the maximum swing angle of the pendulum equals 46, and then determine the pre-impact speed of the bullet B. Huh. Very fascinating. Okay.
A lot
Uh,
of words there.
yeah, a lot of words. I'm a big word guy, so this should be pretty good.
So yeah, so let's approach this like we would any physics problem. Let's
You
write
said
down what
L. Sorry,
owl.
L. Like it's establishing certain variables I haven't really seen before.
L. So the length of the pendulum.
Okay, it's a pretty good one.
So yeah, so they give you L, and that's 1.5 meters. And what else they give us? They give us the mass of the block, which they call it A. So that's 6 kilograms. They give us the mass of the bullet, which is 0.087 kilograms. And that the change in theta is 46 degrees. I think that's all we know, right?
Yeah.
Okay, so let's kind of draw this out. So it's just like what we did a moment ago. You've got your little, you know, that thing, and it's gonna come out to here. It says that the angle it makes is 46 degrees, right?
Uh-huh.
So you've got this little ball. It's gonna hit our box. So what we want to know is how fast is it going before it hits? That's what we want to know. You have any ideas?
Can we send up how fast it's going before? Can we set up momentum like equation, like
Okay.
before and after?
I think that's a great idea. So
Let's go.
let's do it because again, like we're looking at scenario one, right? And then you got scenario two.
Yeah.
So let's look at this. We got oh, and it told us this length. It said it was 1.5. So pendulum has no momentum in the beginning, right?
Yeah.
It's only the mass of the bullet. So mass of the bullet times the velocity of the bullet is going to be equal to the momentum of the two things together.
Yeah.
Now, I do not know any of these velocities, right?
Uh-huh.
I only know the
Oh,
masses.
okay. So, ooh, that kind of
So we are going, I will tell you, we are going to use this, but we can't use it yet.
okay. So we need to find the velocity first.
Okay. So we can't deal with momentum right now. So let's see if we can deal with energy. So earlier in equation two, we did kinetic energy is equal to potential.
Uh-huh.
So you've got 1/2 times your MA plus MB times V squared. And that's going to be MA plus MB times GH. Now, I don't have V and I don't have H. So now it on the surface, it kind of looks like we have problems,
Yeah.
but we don't. And I'll show you. This frustrated me when I first realized it was this simple. So we know that the length of this pendulum is 1.5, right? And we know as it swings, as it makes this arc, it's making this arc at 46 degrees. So would you agree that right here is the height?
Yeah. So that's 0.
So if we actually took this right here, made that a little triangle, we could actually use a little bit of geometry to figure that piece out. So what we're going to do is we're going to take the length of the whole pendulum, that 1.5, and we're going to minus this piece here and here. Because if you take 1.5 and you minus this piece here, what does that leave you with?
1.5 minus that. That would be, what's like -1?
You're going to take L minus this red piece.
Yeah, then you would get the rest here.
You get the rest here, which we've already said is equal to the height.
The height. Okay.
Physics is fun.
A lot
Said physics is fun. Now this is geometry. But yeah, so if we know the full height, if we find cosine, because it's the adjacent angle,
Oh yeah.
and we actually know the hypotenuse, right? Because it's the same string. So as that 1.5 goes here, it's 1.5 here, right?
Okay.
So you just take
Respond to
L.
that.
What? Siri, chill out. Sorry, Siri just
I thought it was mine.
No, it was mine.
Respond to
Don't know
that.
what just happened.
All right, so L minus L cosine 46. So let's do some math here. You got a calculator?
Yep.
Okay. So I'll write this out. We got 1.5 minus 1.5 cosine 46.
Okay, I got like 0.58, which is a very small height, but kind of accurate maybe compared
Yeah, I
to the
bet it is.
1.5.
Because I
Yeah.
mean, it's like a 45-degree angle almost.
Yeah.
Okay, so H is equal to, say it again,
0.458, just to 3 significant figures.
All right. So now we have our height. So let's take that. We'll put that right here. And you see how this term and this term are the exact same?
Yeah.
Let's
Doesn't
get rid of
matter.
them.
So now 1/2 velocity squared is 9.8 times 0.458.
Exactly.
And if I multiply that by 2,
Hmm.
or like divide by 1/2, same thing, and then square root that, you get V.
Yep. So now
Initial
you
V.
have the V as it begins to swing, which is the same V in our equation 1. See how we worked backwards from energy to push our sorry, to solve for one and then get to the other.
Yeah.
Well,
Makes
from here
sense.
it's just algebra, right? So let's make sure you know how we set all that up. So we used all of the same thinking that we did previously. Conservation of energy, conservation of momentum.